The downcomer seals the glycol passage into the tray below to prevent gas from bypassing the bubble caps. As the glycol spills downward through each succeeding tray, it becomes wetter with the water it has absorbed from the gas and collects in the bottom of the contactor saturated with water. This wet glycol then flows out of the contactor and through a filter where any solid and abrasive particles or tarry hydrocarbons are removed before it enters a pump. From the pump, the cool, wet glycol is sent to the surge tank. The surge tank is a holding tank which stores hot, dry glycol produced by the reboiler before it's sent to the contactor column. However, the cool, wet glycol does not actually enter the surge tank. Instead, it flows through the surge tank in coils. This allows for the heat exchange process to occur, which we mentioned in the first section. As the cool, wet glycol flows through the coils of the surge tank, it's warmed slightly before it enters the gas condensate glycol separator. Conversely, the hot, dry glycol stored in the surge tank is cooled before it enters the contactor column. After leaving the coils in the surge tank, the wet glycol enters the gas condensate glycol separator. Now, the purpose of this vessel is to remove the gas and condensate hydrocarbons that were accumulated by the glycol on its path through the contactor. Heat will cause the hydrocarbons to separate from the wet glycol solution. Now, this hydrocarbon condensate is skimmed off the glycol and disposed of, and any remaining gas vapors will exit at the top. From the gas condensate glycol separator, the wet glycol then flows in a tube through the reboiler where it's heated slightly before it enters the still column. Inside the reboiler still column is a section packed with ceramic or stainless steel saddles. The glycol spreads uniformly over these saddles and drips down through the packed section. The distillation or cooking process is started in this section to boil the water out as a vapor from the glycol. From this packed column, the wet glycol drops into the bottom of the reboiler. Here a source of heat is circulated through a tube in the lower section of the reboiler to heat the glycol solution up to around 370 to 400 degrees Fahrenheit, which is just below the boiling and decomposition point of triethylene glycol. Usually waste heat from compressor or generator exhaust gases can be used as a heat source, but many installations also use a gas-fired heater. Remember, the temperature of the glycol in the reboiler is critical and is controlled at this point. Any higher and the glycol will begin to decompose, requiring costly replacement. As the glycol begins to heat, the water trapped by it begins to boil and moves upward through the still column as steam. Mixed with the steam will also be some hot glycol vapors. As this mixture passes upward through the still column, it comes in contact with a cooler part of the column, and the glycol vapors will condense and drop back into the reboiler.